Okay, here's question number 23. A 4-pole separately excited wave-wound DC machine with negligible armature resistance is rated for 230 volts and 5 kilowatts at a speed of 1200 RPM. If the same armature coils are reconnected to form a lap winding, what is the rated voltage and power, respectively, at 1200 RPM of the reconnected machine if the field circuit is left unchanged? Alright, we are supposed to find out what the rated voltage is and what the power is. Let's start by writing down what's given to us. So we now have 4-pole, 230 volts, 5 kilowatts and 1200 RPM. 4 poles, 230 volt, that's the rated voltage. The power is 5 kilowatts. Speed is 1200 RPM. Okay, now the first step is to find out the induced EMF, because that's exactly what we need to find here. We are finding the rated voltage, so we have to find the induced EMF. The basic formula for induced EMF, I'm sure you're familiar with this formula, phi NZ, phi 60 into P by A. So this is the basic equation, induced EMF of a DC machine. Okay, so the question tells us that first it's a wave wound DC machine, then it is reconnected to form a lap winding. So here we have two types. First it was wave wound and then it is lap wound. Now you are quite familiar with the differences, I hope. Let me write it down here for you. Now for lap connected, we have the condition that the number of poles is equal to the number of parallel paths. So that is 4. Since there are 4 poles, there would be 4 parallel paths. But for a wave wound or wave connected, the number of parallel paths is fixed as 2. The induced EMF is inversely proportional to the number of parallel paths. This is an important relation and it will help in most questions that deal with this concept. Now, if this is a relation where the induced EMF is inversely proportional to the number of parallel paths, we can write a relationship between them of lap and wave wound. So take a look at this. So we have E lap, that's the induced EMF of lap winding, divided by EMF of wave winding is equal to the parallel paths of wave winding divided by the parallel path of lap winding. Now the ratio here is 2 by 4, which is equal to 1 by 2 or 0.5. Now take a look at, let's substitute the values here. Now we know what the EMF of wave winding is. That's given to us as the rated 230 volts. So E lap divided by 230 is equal to 1 by 2. Solving this, we will be able to obtain the EMF of the lap winding, which comes to 230 divided by 2, and that's 115 volts. Now we have just found the voltage, the rated voltage we have found as 115 volts. Now we need to find out what the power is. Since the parallel paths are doubled, they are doubled, aren't they? Take a look at this. First, it's wave wound, where the parallel paths are 2. Then it is reconnected as lap winding and it becomes 4. So 2 to 4, we see that the parallel paths are doubling. So when the parallel paths double, you should note that the current also doubles. Okay? When the parallel paths double, the current also doubles. That's an important point. When A doubles, current also doubles. So this means that I wave now becomes 2 times I wave. Okay? I hope that makes sense. Now, let's calculate the power for lap winding. The power when the machine is connected in lap winding would be equal to the rated voltage of lap winding into the current of lap winding. This general equation of power equals to voltage times current. The induced EMF of lap winding is the induced EMF of wave winding divided by 2, and the current of lap winding is twice the current of wave winding. We just saw that, 2 times I wave. Because the parallel paths double, the current will also double. Now, what happens here? 2 and 2 cancels out, and this gives us E wave into I wave. Now, E wave into I wave is P wave, the power at wave winding. So here we have, or we see, that the power of lap winding is equal to the power of wave winding. So the power doesn't change, it remains the same. That indicates that the power given to us in the question of 5 kilowatts remains the same as 5 kilowatts. So here is our final answer. The induced EMF or the rated voltage is 115 volts and the power is 5 kilowatts. Now let's see which option it matches with. It matches with option B. So here is the entire solution and I hope it helps.